if I equal to 12 milliampere, find the current in other resistor, also find VAB. This is of 10 kilo ohm resistor and this is of 20 kilo ohm resistor. It is a 100 kilo ohm and it is a 5 kilo ohm, and because it is given that I 12 milliampere is flowing in this resistor. Now this current will divide into two parts, I1 and I2, and again it will add up to give I ampere. So from KCL we have I equal to I1 plus I2. So that is, so current in 100 kilo ohm will be I equal to 12 milliampere. Now from these 2 points we can write Vp minus Vq equal to I into R, I1 into R. So 20 kilo ohm into I1. Also from, if we see this resistance, then Vp minus Vq will be 10 kilo ohm into I2. Now these two are equal, so 20 kilo ohm I1 equal to 10 kilo ohm I2, 2 I1 equal to I2. This is equation 2. Now from 1 I1 equal to I minus I2, using in 2, the putting that is value of I1 in 2, so 2 into I minus I2 equal to I2. This implies 2I minus 2I2 equals to I2, or 2I equal to 3I2, hence I2 equal to 2 by 3I, or 2 by 3 into 12 milliampere equal to 8 milliampere, and I1 equals to I2 by 2 equal to 8 milliampere by 2 equal to 4 milliampere. Answer. Next, an ideal battery sends a current of 5 ampere in a resistor. When another resistor of value 10 ohm is connected in parallel, the current through the battery is increased to 6 ampere. Find the resistance of the first resistor. Now we have to solve this problem. So let's see. The situation is shown in here in the figure. That is, I1 current is flowing in this resistor R1, and its value is given I equal to 5 ampere, and it is the EMF of the battery. So we have we know that I1 will be equal to E by R1, so E equal to I1 R1 equal to 5 R1 equal to equation 1. Now when another resistance R2 is connected in with parallel, then current in this circuit becomes I2. So here I2 equal to 6 ampere. Now I2 will be given as E by R equivalent. So E by R equivalent R1 into, because these are in parallel, so R1 into R2 by R1 plus R. This implies E equal to 6 R1 by R2 by R1 plus R2. Now given R2 equal to 10 ohm, and C equals to 6 R1 into 10 by R1 plus 10, 60 R1 by R1 plus 10. This is equation 2. This is the value. So using the value of E from 1, now from 1 and 2, 5 R1 equal to 60 R1 by R1 plus 10, or 5 R1 square plus 50 R1 equal to 60 R1, or this implies 5 R1 square equal to, this will come in this side, so minus 10 R1, or equals to, taking 5 R1 common, so R1 minus 2 equal to 0. This implies 5 R1 equal to 0, or R1 minus 2 equal to 0. Since R1 cannot be 0, so we have R1 minus I2 equal to 0. This implies hence R1 minus R2 equal to 0. This gives R1 equal to 2 ohm. Answer. Each side has equal resistance 15 by 6 ohm, as shown in the figure. We have to find RAB, that is equivalent resistance between point A and B, and RAC, equivalent resistance between point terminal B and C, that is A and C, and RAD, equivalent resistance between terminal A and B, that is point A and B. Now we have first we find the equivalent resistance Rab. Here it is shown the corresponding figure of resistance with resistance. This is the point A and B. We see that these all are in series, and these equivalent of these series resistance will be parallel with this resistance, which is shown here. So because 1 2 3 4 5, so this will be 5R and it is R. So Rab equal to 5R into R by 5R plus R equal to 5R square. These are in series, so R1 plus R, this add up to 5R. So these are in now parallel. So Rab will be 5R into R divided by 5R plus R equal to 5R square by 6R, or 5 by 6R equal to 5 by 6 into 15 by 6 equal to 25 by 12 ohm, or 2.08 ohm answer. Next, second case. In this case, here it is shown the equivalent circuit. We have to find the potential equivalent resistance between R and C, point A and C. So now this will be in series, again this will be in series. So first, and these two will be again in parallel. So equivalent of these two is 2R and equivalent of these are 4R. So RAC will be 2R into 4R by 2R plus 4R, 8R square by 6R equal to 4 by 3R. Putting the value of R is 15 by 6. So we have RAC equal to 10 by 3 ohm, 3.33 ohm. Next, third, and this is the shown condition. We have to find the potential that is equivalent resistance between A and D. So this all will be in a series, again this will be in series. So equivalent circuit is shown here, 3R by 3R and 3R, and now RAD will be 3R by, because both are equal, so in parallel we divide. It's 3R by 2, so 3 by 2 into 15 by 6 equal to 15 by 4 ohm, or 3.75 ohm answer. Next question. Find the current through the 10 ohm resistor when the switch S is open, A, and B closed. This is shown the circuit. We have to find the current in 10 ohm resistor when this is open and when it is closed. Now in A it is open, so this circuit, this resistance will not be short circuited. Now this two will be in series, so I will be equal to E by R equivalent, 3 by 10 plus 2 equal to 3 by 30, 1 by 10 equal to 0.1 ampere. Now when it is closed, this is the case of short circuit, that is current will flow through this, then this resistor, there is no current through this resistor, so this is of not, so our circuit is left with only one resistance, our resistor. So I will be 3 by E equivalent by 3 by 30 equal to 0.3 ampere answer. Next, find the current through the resistors as shown in the figure. This is a 4 volt battery and 2 volt battery, and these are the resistor connected, and again this is short circuited, so no current will flow through this circuit. Now our equivalent circuit will be converted into like this, and using KVL, we in this circuit we consider that is I current is flowing in this. So KVL equals to, start from this figure, minus 4 into I, because we are going from higher to lower, so lower minus higher will be negative, so minus 4I, and again it is will be minus 6I, and this is in this we are going from higher to lower, so lower minus higher will be negative, minus 2, and here we are going from lower to higher, so higher minus lower will be positive, so plus 4 equals to 0. Now this implies 10I plus 2 equal to 0. This implies 10I equal to 2. Hence I equal to 2 by 10 equal to 1 by 5 ampere answer. Next question is find the current through the three resistors if VA equal to 30 volt and VB equal to 12 volt and VC equal to 2 volt. That is the potential of this point is given. It is of 30 volt, it is of 12 volt and it is of 2 volt. Then we have to find the current through each resistor. It is a part of any closed circuit, closed loop and or closed network. We have to find the value. Now at this point, if we consider that is I current is flowing, then at this point I will be divided into two parts. One I1 in this through this resistance and I2 through this resistance. Now using potential drop and potential rise concept, that is VA, we are going minus 10I, we are going that is lower minus higher negative, so minus 10I, and here again we are going from higher to lower, so lower minus higher will be negative, to minus 20I1 will be equal to VB, or this implies 30 minus 10I. V, the value of V is given, 30 minus 10I equal to minus 20I1 equals to 12, or this by 30 minus 12 equal to 10I plus 20I1, or 10I plus 20I1 equals to 18. This is equation 2. That is 10I plus 10I plus 20I1 equal to 18. This is equation 2. Now moving along ADC, that is A, D and C. Now potential of VA, so VA minus 10I and minus 30I2 equal to VC, so VA minus VC equal to 30I plus 10I plus 30I2, VA minus 10I minus 30I2 equal to VC, so VA minus VC equal to 10I plus 30I2, this implies 10 minus 2 equals to 10I plus 30I2, or this implies 10I plus 30I2 equal to 28. This is equation 3. Using 1 into we get 10 into I1 plus I2 plus 20I1 equal to 18, or this implies 30I1 plus 10I2 equal to 18, or using 1 in, this is equation 4. Now using 1 in 3, we have 10 I1 plus I2 plus 30I2 equal to 20, or this implies 10 I1 plus 40I2 equal to 28. Now we have equation in I1 and I2, so we can solve it easily. Now from equation 2 we subtract equation 5 multiplied by 3 gives, or equation 2 minus equation 5 into 3 gives equation 2, the 30I1 plus 10I2 minus 10I1. Equation 4, this is equation 4. Equation 4, here it is equation 4. 30I1 plus 10I2 equal to it. So 30I1 plus 10I2 left hand side. And now the equation 5 we have to apply minus, so 3 into 10, so minus 30I1 minus 120I1 equals to 18, and minus 3 into 28 equal to 18 minus 84 minus 66. This implies 10I1 cancel, so we have left minus 1 10I2 equals to minus 66, or this implies I2 equal to 66 by 11 into 10 equal to 0.6 ampere. Again from 4, 30I1 plus 10 into 0. Because putting the value of I2, 0.6 equal to 18, or 30I1 equal to 18 minus 6 equals to 12. Hence I1 equal to 12 by 30, 4 by 10 equal to 4 by 10 equal to 4 ampere, hence I equal to I1 plus I2. 0.6 plus 0.4 equals to 1 ampere. Answer. Next, find the current through the resistor A and B in the circuit shown. This is the A and this is the B in case 1, and in case 2 let's solve this. Now solution, the current distribution is shown in the figure, that is I current is flowing, and here at this point it divide into I1 and I2, and this circuit it is goes I2, again this I1 it flow in this, and at this point again I1 I2 add up and gives in this I current is flow. So taking KVL in loop ABCA in this loop, so this will be 10 minus because going lower minus higher, the 10 into 10 minus 10 I2 equals to 0. This gives I2 equal to 10 by 10 equal to 1 ampere. Again KVL in loop BDEFCB, BDEFCB, so it will be equal to minus 10, lower minus higher, minus 10. Again here minus 10 I1 because I1 is flowing, and again we are going, then is plus 10 I2, plus 10 I2 equal to 0. This imply minus 10 I1 plus 10 into 1, putting the value of 1, and this will cancel. This imply minus 10 I1 equal to 0, hence I1 equal to 0. So in circuit I1 current is 0 and I2 is equal to 1 ampere. Answer. In the second case, we have to find the current in this A. To consider I current is flowing, and at this point in this circuit going I2 and this circuit I1. Again at this point it is divided into I3 and I2 minus I3, and now this will be I2, and this will be in this part will be I. So KVL, applying KVL in ABGH, we have I1 minus 10 I1 plus 10, here it is plus, the plus 10 equal to 0, this gives I1 equal to 1 ampere. And KVL in BCFGB in this mesh, so this is I1, so we are going lower minus higher, so and it is 10 ohm, so minus 10 I2, and in this I2 minus I1 is flowing, again lower minus higher, the minus of 10 into I2 minus I3, minus of 10 into I2 minus I3, plus in this case we are going from higher lower to higher, so higher minus lower positive, so 10 I1 plus 10 I1 to 0, this implies minus 10 I2 plus 10 I3 plus 10 into 1 equal to 0, or this implies 10 equals to 20 I2 minus 10 I3. This is equation 2. Even applying KVL in CDEFC, then in this case will be minus 10 into lower to higher, so higher minus lower will be positive, minus 10 plus 10 into I2 minus I3. Here it is shown in minus 10 plus 10 into I2 minus I3 equal to 0. This implies 10 I2 minus 10 I3. 10 is in this side, so 10 equals to 10. This is question 3. Now subtracting 3 from 2, that is 2 minus 3, equation 2 minus equation 3 gives 2, equation 2 minus 3 gives 20I2 minus 10I3 minus 10I2 plus 10I3 equal to 0. This implies 10I2 equal to 0, or this implies I2 equal to 0. Now from 3, 10I2 minus 10I3 equal to 10. Hence 10 into 0 minus 10I3 equal to 10. Hence I3 equal to minus 10 by 10 equal to minus 1. Hence I3 equal to minus 1. Negative sign shows that the our assumed current is flowing opposite to our assumed direction.